Hoover High School AP Chemistry. This is lesson number 11 on chemical equations. So chemical equations are the centerpiece of the study of chemistry. Chemical equations are a recipe that shows how reactants combine into new substances called products. So the chemical compounds or substances on the left-hand side of the arrow are the reactants. That's what you're putting into the chemical reaction. And those on the right-hand side are called products. That's what you expect to come out. That's what will come out of the chemical reaction. The one-way arrow indicates the reaction moves from left to right. We'll see situations where the reaction can move in the other direction. That comes later on in this course. Alright, particular diagrams provide a simple picture of the motion of atoms in a chemical reaction. The way the chemical compounds break apart and recombine will be covered later in this course. Particular diagrams show a beginning and final diagram of a reaction. It might also show an intermediate state of the reactants. So on the left, in the reactants, we have one methane molecule, CH4, and we have two O2 molecules. Again, the subscripts are the number of atoms in the molecule. So 1 carbon, 4 hydrogen. And the oxygens have 2 oxygen atoms. The coefficients, the numbers out in front, tell how many of the molecules you have. So you have 1 CH4 molecule and you have 2 of the O2 molecules. Now somehow, through a process we'll study later on in the course, they break apart. Really, chemistry is all about atoms, molecules smashing into each other and breaking apart so that they can recombine. So the intermediate stages, they have to all break apart. It doesn't just happen by magic. There have to be physical laws that govern how that happens, and we'll talk about some of those. And then finally they are put back together and they recombine. Now why don't they get put back together in their original state? Sometimes they do. In some reactions they do. But in the reactions we're going to be talking about at the beginning, we're going to assume that they have an energetically more favorable reason to recombine as products than they were as reactants. If that's not the case, there will be no chemical reaction. Alright, so let's go ahead and balance this equation using the box method. So we've broken out each of the atoms individually. So there's 2 V's in V2O5 and there's 5 O's, so you draw 5 O's. HCl has 1 of each, and you can see how that works all the way across. Alright, so what you do is you pick an element to balance. You want to avoid a couple of types of elements though, or compounds, not necessarily elements. Could be molecules, could be compounds. You want to avoid something that is a sole element, like O2 appears oftentimes in reactions that you'll see. You don't want to start with that, because it doesn't help you balance any of the other elements. And then secondarily, you want to avoid any elements that appear more than once on the same side of the arrow. If you look over on the right side, you'll notice that there's an O in VOCl3 and there's another O in H2O. You want to avoid that. That complicates matters. Save any that appear more than once on the same side of the arrow. Save those for the end of the problem, okay? So what we're going to do is we're going to pick one that looks easy to balance. It looks like V would be easy to balance. There are 2 V's on the left. There's 1 on the right. So what we do is we add a box to the right. Whichever side has the least number, you add a box to that side. So we added a box to the right. So now we have 2 V's on the right and 2 V's on the left. Now you can't just add the V over on the right side. You have to add everything else that's a part of that compound. So you have to add the O and the Cl and Cl and Cl again. So now, however, we have the V's in balance. Now what are we going to balance next? You could pick H, you could pick Cl. We're going to go ahead and try to balance Cl. Now you notice we have a whole bunch of Cl's on the right. We have 6 of them in all, if you count them. So that means we're going to have to add 6 boxes to the left to make the Cl's balance. So there's 2, 3, 4, 5, 6. So now we have 6 Cl's on the left, 6 Cl's on the right. They're in balance. Our V's are still in balance. They didn't go out of balance. So really the next thing we want to try to balance is H. And you see now that on the left side, because we added all those boxes, we now have 6 H hydrogen atoms over on the left. So we need to get 6 over on the right. So what are you going to do? Think about it. What do you add? How many times do you add a water molecule? Well, you add it 1, 2 times. So now you have 6 H's on the left and 6 H's on the right. Now we only have one left, and that's oxygen, and you'll notice, and this is not unusual, it just happens to balance. Now that we've got the other three elements in balance, you notice that on the left, you always had those 5 O's sitting over there on the left. On the right now, if you count the O's on the right-hand side of the arrow, there's now 5 of them there. So that is a balanced equation. So the way you write the coefficients is simply how many boxes you have. So down there at the bottom, you have 1 V2O5, you have 6 HCl, you have 2 VOCl3, and you have 3 H2O. And that's a balanced equation. You have the same number of atoms of each type before the arrow and after the arrow. You can't create or destroy atoms, so you have to have that happen. And it's necessary to do this anytime you're going to use a chemical equation. All right, now I'm going to show you a little more advanced way, a little more sophisticated way. And it's going to seem harder and more confusing, but eventually you'll get to where you do a lot of these in your head. It's like doing basic math. If you're good at basic math and you practice it a lot, you can multiply 2 numbers in your head and then add a 3rd number. You can do a lot of things in your head. But I'm going to show you how you actually write it out. It'll seem a little trickier this way, but it's the way you eventually want to move towards. So the first thing you do is, it's just the standard way of balancing chemical equations. And what you do is just write each of the elements down below the arrow. So each element, we have V, we have O, H, and Cl. Those are the 4 elements in this particular chemical reaction. Now what you do is you count how many atoms of each are on each side. So for V, we have 2 V on the left, and we have 1 on the right. For O, we have 5 on the left, and we have 1, 2. You have in 2 different places, so you have 2 on the right. For hydrogen, you have 1 on the left, you have 2 over on the right. Again, we're counting atoms here, individual atoms of each of the elements. And finally, for chlorine, you have 1 on the left, and you have 3 on the right. So by the end, you have to have all of those numbers equal, same number of atoms on the left as on the right. So let's start, again, we'll probably start with V again, it seems easier. But what you're going to do is just kind of mark out a number as you use it and write the new number. So if we put a coefficient in front of that VOCl3, then we'll have 2 V's. Now the reason I put it up above is when you do these actually on paper, it's good to do that because that may not be the final coefficient for that. So I leave space down below for what is the final coefficient. So we're going to put that up above. So what it means is we have 2 V's. So you scratch out the 1 and you put a 2 for V. But remember, that coefficient distributes throughout that entire compound. So you also have 2 O's now in VOCl3. So you scratch out the 2, so you have 2 O's in VOCl3, and you also have another one in H2O. That's a total of 3 O's on the right-hand side of the arrow. Okay, what else changes? See if you can think of what else is going to change and how is it going to change. Okay, that 2 is going to distribute to the chlorine 3, the 3 atoms of chlorine over there. So 3 times 2 is 6. So you now have 6 chlorine on the right-hand side over there. Okay, let's keep going. What are we going to do next? Well, let's see. We have HCl over on the left. So we're going to balance the Cl's. We just put a 6 in front of HCl. And now we have 6 hydrogen and 6 chlorine. So the chlorines are in balance. There's 6 on the right-hand side. Now there's 6 on the left-hand side. So what we're going to do is we're going to, first of all, scratch out the 1 for the hydrogen and put the 6 there. So you have 6 hydrogen. And we're going to scratch out the 1 for the chlorine and put 6 there. Okay, so we're making progress. Okay, so now we have the V in balance and we have the chlorines in balance. Now let's go for hydrogen. You have 6 on the left, 6H. On the right you have 2. How do you turn that 2 into 6? What do you put as a coefficient to make that H2 become 6 hydrogen atoms? Well, you put a 3 in front of it. So 3 times 2 is 6 hydrogen atoms. So down there on our scoreboard down there, we scratch out the 2 and put a 6. So now 3 of the 4 elements are in balance, V, H, and Cl. The only one that's not is the oxygen. But it is, isn't it? You have 2 oxygens in the VOCl3. You have 3 oxygens in the H2O. That's a total of 5. And over on the left side, you always had those 5 over there on that side. So you scratch that as a 5, and now you see all the numbers are equal. So that gives us the same thing we had in the last slide, the same coefficients. Okay? So this takes a little bit of practice. Believe me, you'll get a lot of practice on these in the next week, and you'll become very proficient at these. Okay, so that takes care of it for chemical equations and balancing equations. Again, a chemical equation is no good to you unless it's balanced. So you have to learn to do that, and you'll get some practice on that in the lesson, in today's lesson. All right, so take care. We're going to give you another lesson tomorrow. Get done with these, and we'll see you then.